Hello and welcome back to the lecture on applied econometrics. We have been talking about instrumental variable, and in the last two lectures we spoke in detail about the problem of endogeneity, and specifically we spoke about the problem of simultaneous equation model. Now, in all these cases, we have seen the heart of endogeneity problem lies with the fact that whenever we have a situation where my covariance of x and u is not equal to 0, or in other words, when x and u are not independent, so then we have this problem of endogeneity. Now, why exactly it is a problem? So to in very simple word, we can say x. We are basically interested to know in regression equation the influence of x on y. So we basically get a regression coefficient for x for x. Now, when x is influencing u, since u in this model is also determining y, so essentially what is happening, because x is influencing u, so we are getting a distorted coefficient beta for x, right? So that we do not want. So essentially I want a variable instead of x which is actually free from u, so that I can have covariance of that specific variable with the error term is 0. So if I can find a particular variable that I can suitably substitute, that which can be a suitable substitute for x, so then that can actually play a role to actually remove the problem of endogeneity. And I claim that instrumental variable, or a good instrumental variable, can actually do this job. Okay, so let us actually look at our example. So previously, in our previous class, we talked about this equation where price rate is basically dependent on the wage rate and the error term. Okay, so we said that the wage rate in the previous equation, we said that the wage rate was actually endogenous. So in a way, wage rate is also getting determined by the price rate. So what is happening here is wage rate and the error term UP are not independent. So when I actually obtained the reduced form equation for price rate or wage rate, we saw that wage rate is having a component in its expression that actually have this UP term, right? So when I take a covariance, so when I actually estimate the beta OLS for the price for basically for this beta 2, so the B2 OLS is going to have a term where my W, so I'll have a covariance of WUP. I'll have a covariance of WUP. So I'll have a beta 2 plus covariance of WUP by variance of W. Now, because W and UP are not independent, so what I'm going to have is this term is not going to be 0. This term is not going to be 0 because they are not independent. And even asymptotically, that is the case. So essentially, I get a B2OLS which is biased and inconsistent. So I want to basically get rid of this, right? And that is basically the source of endogeneity. So I want to get rid of this, and to get rid of this, there is a way to actually get rid of this. And if you remember, the second equation we had previously is W is equal to alpha 1 plus alpha 2 into price rate plus alpha 3 into unemployment rate. This is a capital U plus UW. All right. Now, this particular variable, capital U, is coming not from the equation. It is not determined by the equation. It is not an endogenous variable, but rather it is an exogenous variable. It is coming from outside. Okay, and this u is not there in this equation. Okay, so if I can actually replace w with u, so what I'll have, the first thing that I'll have is that this correlation between error term and the x variable w will go away, and that basically would solve the problem of this endogeneity. Now, only point is whether I can suitably substitute w with u. Okay, so that is basically the criteria we have to see. But let's say we can substitute w with u. So if we can do that, so then that will be an IV, and we have seen previously for an IV estimator we can write B2 IV is going to be beta 2 plus I have in this case now my IV, let me actually write down in covariance term, covariance of x covariance of yz divided by covariance of xz, right? In this equation, in our equation, y is the price rate, x is the wage rate, and my z is u. All right. Now, if I use this formula and if I actually sort of expand it, so what I'll get is B2 IV is equal to summation of Ui minus U bar into Pi minus P bar divided by summation Ui. These are all capital U. Ui minus U bar, unemployment rate, and then I have Wi minus W bar, right? Now we can expand it, and if I substitute the value of this Pi P bar, so what I'll get is this. Let me write down the numerator only. Numerator is going to be summation of, so basically let's take the Pi minus P bar term first. So beta 1 plus beta 2 Wi plus UPI. So for ith term it is UPI minus beta 1 minus beta 2 W bar minus UP bar, right? And then I have Ui minus U bar, right? So we are familiar with this expansion, and what we'll get is I'll cancel this beta 1, I'll get a beta 2, and then I'll have a beta 2 here, and I will have Ui minus U bar into Wi minus W bar, and let me reduce the size, and then I'll have the same term here, but I will have Ui minus U bar and small u p I minus up bar, right? So that's what I'll get. Now, if I divide by the denominator, so this is going to be simple beta 2, okay? This is going to be simple beta 2. So let me write down the final expression. So B2 IV is going to be beta 2 plus summation capital UI minus U bar into small UPI minus UP bar divided by the denominator term, which is capital Ui minus U bar and Wi minus W bar. All right. So let me use a new page. Let's not clutter it further. And if I actually take Pilim on both the sides, what I'll get for Pilim beta 2 OLS, beta 2 IV is going to be here beta 2. This is constant term, and here I will have Pilim on both numerator as well as the denominator. So let me take that Pilim, and let's divide each of these with 1 by n. So essentially, I will have capital Ui minus capital U bar into small UPI minus UP bar, and in the denominator I will have Pilim 1 by n summation Ui capital Ui minus U bar into Wi minus W bar, right? Now this term above, so essentially what I'll get is beta 2 is equal to covariance of U and UP, let's say, and the denominator I have covariance of U and W. Okay. Now U and UP, they are independent, right? In the previous structural equations, we have seen that these terms are independent because U is exogenously given, and even when I substitute that in this equation, it doesn't really make a difference in terms of when you consider the relationship between U and UP. UP is something that is determined by the price rate equation, so it has nothing to do with U. So they are independent. So that I can convincingly argue. So because we can have this, they are independent, the U and UP, I can claim that this term is equal to 0. Okay, and the denominator term, the W and capital U, again they are not 0 because capital U is a important regressor for the second equation here. For wage rate, I have my U, which is my regressor for wage rate. So if there's a regressor, so then it cannot be the covariance cannot be 0. So and I'm assuming they have a strong correlation, and that is why I have included capital U in the regression term. So it is not equal to 0, and that is basically with this formulation I will get B2IV is equal to beta 2. B2IV is equal to beta 2. So it is basically unbiased and it is consistent, because for large n I am getting B2IV is equal to beta 2. Now in the next lecture we are going to talk about how these relationships, like here we see that they are not this is not equal to 0, but on what conditions this u can be a good substitute of x. So that is something we need to explore further. We have assumed that u is actually a good substitute of x, but is it always the case? And that is what we are going to see in the next lecture when we talk about a good IV or a bad IV or a weak IV. With this, we end this lecture here. Thank you.